Hello everyone. Today we are going to another rules of electronic transitions or filling of electrons in SPDF state. In previous class we all our study for the electrons are fill in a state, then to a state, then to P state. From A state there is a 2 electrons fill, but in case of P state there is a 3 orbitals px, py, pz. Similarly D state there is a 5 orbitals. Okay, now today we are going to learn about Hund's rule, how Hund's rule come after Habermas principles. There is some field of electrons in 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10 state. As we know, hydrogen have a atomic number Z is equal to 1. So its electron 1s1, that is in one state. One electron fill in a 1s orbitals. Similarly for helium, for lithium, for berylliums. But in case of boron, we see here 1s2, 2s2, 2p5, because boron has a atomic number Z is equal to 5. P is equal to 1 means 1 electrons, but there is a 3 possible orbitals, means px, py, pz. Px, py, pz. Okay, means px energy and py energy and z energy have a equal contribution. Px orbitals have equal contribution, means this electron come here, or this electron come in here, or this electron come here. But when we go to the another carbon state, carbon atom, that is equal to 6 atomic number, and its valence shell is 2p2, means 2 electrons in are arranged in px, py, pz. So these 2 electrons are arranged in parallel way or in anti-parallel way, means this also can be arranged like this also. Okay, Hund's rule, it is based on the electron pairing. Hund's rule basically based on the pairing of electron in these orbitals. Electron prefer to remain unpaired as far as possible. Means electron in a subshell are paired only when all the orbitals of a subshell is half filled with the parallel spins. Means all the, suppose another example, for nitrogen Z is equal to 7. Here is 1s2, 2 electrons are filled, 2s2, 2 electrons filled, but in case of 3, here 3 electrons. So px, py, pz have 1 1 1 electron with a parallel spins or anti-parallel spins. Then after, means electrons in a subshells are paired only when all the orbital of a subshell is half filled. All the orbital have a half fill with a parallel spin, half filled. But in case of Z is equal to 8, for oxygen there is a 1s2, 2s2 and 2p4, and there is a 4 electron, but there is a 3 orbital px, py, pz. So electron first fill half parallel spin, means off spin, electron first fill half parallel spins. Then because p4 1 2 3, then for another electron the relay again first fill parallel spin, half parallel spins, then from here. Similarly for p5, Similarly for p5 what happened? 3 orbitals, this is px, this is py and pz. Electron first fill half parallel pins, means 2 3, then 4, then 5. Similarly for p6 it is electron fully filled, means 1 2 3, then 4 5 6, this is fully filled. In this way Hund's rule get idea how electrons fill in its orbitals in SPDF states. So today is the complete discussion about Hund's rule. Next class we will discuss some of the question about Hund's rule. Okay, thank you.